In this topic of discussion, we are going to see about color fundamentals and models. There are two things, physical phenomenon and physio-psychological phenomenon. In the first case, physical nature of the color will be known to us very clearly. And physio-psychological phenomenon, we can say that how human brain perceive and interpret the color. Sometimes a cyan color or blue color and green color will be known to the pupil in different way. Everyone will perceive the color in different way. Sometimes in general puzzles we would have observed this and we would have heard this. Everyone will be perceiving the color in a different way. That is called physio-psychological. Physical quantities to describe a chromatic light source or radiance, luminance, brightness. Radiance is the total amount of energy that flow from the light source measured in watts. Luminance is the amount of energy an observer perceives from a light source measured in lumens. Far infrared light, it will be very high radiance, but that will be zero luminance. For the brightness, it is mean to subjective descriptor that is hard to measure, similar to the achromatic notion of intensity. What are all the color models available? We can see now color model, color space, color system all are in same way. A coordinate system that each color is represented by a single point. There are types of color models RGB, CYM, CYMK, HSI. We will be seeing one by one. RGB is the basic color model red, green, blue. All the combination of colors will be arising from these combinations of colors called red, green and blue. CYM and CYMK model are suitable for hardware or and applications. HSI model will be used for the matching the human description. RGB color model. This is the cube which represents the RGB color model. We could see the corners of the cube is meant to be red for coordinates 100 for red, for green 010 and for blue 001. Same way the another colors combinations like magenta, white, cyan, yellow are also placed in the remaining corners of the cube. The color combination will be if we form full green with full red, it will give you a yellow. Same way, green with blue, if we combine, it will give the cyan color. Red and blue is mixed, we will be getting the magenta color that is shown in this cube. Red, green, blue. If it is equally mixed, it is the white color we get. And this is the combination of colors using a Venn diagram. Safe RGB colors, which means that a subset of colors is enough for some applications. Safe RGB colors like safe web colors, safe browser colors, and the equivalent color equivalent hex and decimal number systems are shown. Valid values of each RGB component in a safe colors are given. CMY is secondary colors of light or primary colors of pigments. They are obtained by subtracting 1 RGB from the one value, that will be the CMY, that is the counterpart of RGB. Like 1 minus RGB is equal to CMY. Cyan is negative of red, magenta is negative of green, yellow is negative of blue. So they are used to generate hard copy output. If I add black with this, this is called CMYK. K represents black color. HSI color model. Hue means color attribute. Saturation in the sense purity of color. White will be 0, primary color will be 1. Brightness, achromatic notion of intensity. So red color falls between 0 and 60 degrees is the HSV cone. Yellow color falls between 61 to 120 degrees. So like that, all the color values where it falls on in the HSV cone is given. Here is the conversion of RGB to HSI model. So any model can be derived from the basic RGB. The intensity line is shown in a dotted lines. So where we could see the saturation part, colors on this triangle have the same hue. So this is the color cube where HSI can be derived. Next comes the YIQ model. YIQ is the most widely color model used in television broadcasting. Y stands for luminance part, IQ stands for prominence part. In the black and white television, only the luminance part was broadcast. The Y value is similar to the grayscale. Color information is represented by the IQ part. So how to derive the RGB to YIQ? If I want to have a YIQ value, this is the formula we should apply with the matrix value multiplied with the RGB component. Same way, if we want to inverse the value to derive the RGB from YIQ, we have to use the corresponding matrix. Thank you.